Let's take a look at the last question. Lisa is looking at a blueprint of her apartment, shown below. She wants to know the total area of her apartment. She writes the equation 7 times 7 plus 1 times 4 to calculate the total area. Do you agree or disagree with her equation? Explain. What can we do to determine if Lisa's equation is correct or incorrect? Say it out loud. Yes, we can begin to solve the problem on our own and compare it to Lisa's work to see if we agree with her thinking. What is the first step that you would take to solve this problem? Say it out loud. I heard some scholars say that they would first extend the line where the gap is so that they can create the complete rectangle as well as the complete cutout. Great job. What can we do next? Say it out loud. Right. We want to find the area of the larger rectangle by multiplying the length and the width. What is the length of the larger rectangle? Correct. The length of the larger rectangle is 7 units. What is the width of the larger rectangle? Yes, the width is also 7 units. And when we multiply these, that will give us the area. What is the area of the larger rectangle? Yes, 7 times 7 equals 49 square units. Great job. What can we do next to help us solve this problem? Say it out loud. That's correct. We can find the area of the cutout rectangle by multiplying the length and the width. What is the width of this rectangle? Correct. The width of this rectangle is 1 unit. And what is the length of the cutout? Yes, 4 units. When we multiply them, that will give us the area. What is the area of the cutout rectangle? Correct. 1 times 4 is 4 square units. What equation could we write to represent how we could use this information to solve for the area of the original figure? Say it out loud. Yes, we could write 7 times 7, which represents the area of the larger rectangle, and subtract 1 times 4, which represents the cutout, equals A. Do you agree with Lisa's equation? Explain your reasoning out loud. I heard many scholars say that they do not agree with Lisa's thinking because Lisa added the area of the cutout instead of subtracting it. They also mentioned that adding the figure would make sense if we had a rectilinear shape that could make 2 complete rectangles, but that since we are cutting out this rectangle or removing it from the original shape, we would not want to add it on in another area. We would want to subtract it from the original area. Great job, mathematicians.